So in today's lesson, we are looking at some number theory question at SMO2021 Junior section. This is question number 6. X is a positive integer such that the LCM of x14 equals to 42 and the LCM of x33 equals to 66. If so, what is the value of x? Now we will look at this again. The LCM of x and 14. 14 is 2 times 7. And this is 2 times 3 times 7, which means that x must be a multiple of 3. So x is a multiple of 3 in this case. For the second one, the LCM of x 33 is 3 times 11, and 66 is 2 times 3 times 11. It means that x must be a multiple of 2. X is a multiple of 2. And when we combine these two, it means that x must be a multiple of 6. So x must be a multiple of 6. And since this is 6 times 7 and 6 times 11, so x must be equal to 6. And therefore, x can be only equal to 6. The answer for question 6 is 6. For question 7, we are asked to find what is the last 4 digit of this sum. So we have 1 of 1, 2 of 2, 3 of 3, 4 of 4, and so on and so forth until 9 of 9. So because we only want to get the last 4 digit, so we can combine the first one and the last one. After we combine the first one and last one, the last 4 digit will be all equal to 0. So it won't affect the last 4 digit of the sum. Then we can continue to consider 2, 2 and 8. 8, 8, 8, and 3, 3, 3, 7, 7, 7, 7, 4, 4, 4, 4, 6, 6, 6, 6, and last one is only 5, 5, 5, 5. And for this will be equal to 8910, and this will be 0118, and this will be equal to 0111, and this is 5555. So when you add up these 4 digits, we will have, this is 5, this is 8, this is 6, and this is 3. So the answer for question 7 is 3685. For question 7, we are asked how many distinct triples of positive integer ABC satisfy this inequality. 1 is less than or equal to A, less than or equal to B, less than or equal to C, and this equation 1 over A plus 1 over B plus 1 over C equals to 1. From the inequality, then we know that 1 over A, 1 over B, 1 over C will have this relation. That is 1 over A greater than or equals to 1 over B greater than or equals to 1 over C. And all of them must be strictly less than 1 because the sum is equal to 1. So 1 over A plus 1 over B plus 1 over C will be greater than or equals to 3 over C and less than or equals to 3 over A, because 1 over A is the largest and 1 over C is the smallest. So 1 will in between 3 over C and 3 over A. And therefore from here, C will be greater than or equals to 3 and A must be less than or equals to 3. We know that A less than or equal to 3 is more important information. Now we already know that A cannot be equal to 1, otherwise there's no solution for B and C. So we have only 2 cases, that is A equals to 2 or A equals to 3. So for A equals to 2, then we'll have 1 over B plus 1 over C equals to 1 minus half, that is a half. B plus C over BC equals to 1 over 2. 2 of B plus C equals to BC. So this can be written as B minus 2, C minus 2 equals to 4. And note that 4 can be written as 1 times 4 and 2 times 2. And since B is smaller than C, so we will have B minus 2 equals to 1, C minus 2 equals to 4, or B minus 2 equals to 2, C minus 2 equals to 2. So in this case, we will have A, B, C equals to 2, 3, 6, or 2, 4, 4. If A equals 2, we have two different solutions. Now, what happened when A equals to 3? So let me continue here. When A equals to 3, if B and C are all greater than 3, then 1 over A plus 1 over B plus 1 over C strictly less than 1 over 3 plus 1 over 3 plus 1 over 3, because B and C strictly greater than 3, and this is equals to 1. So this will be a contradiction. It means that the only possible case is when A, B, C all equals to 3. With this, when A equals to 3, there's only one solution. That is all A, B, C equals to 3. For this question, we'll ask how many distinct triples, and the answer is equals to 3. And we have these three solutions. For question 9, we are given 5 consecutive positive integers, and the product of the largest and the smallest is 2021. The question asks, what is the sum of the 5 integers? For 5 consecutive positive integers, usually we start from x, x plus 1, x plus 2, and so on and so forth. But we also can start with x minus 2, x minus 1, x, x plus 1, and x plus 2. So from the condition, the product of from the largest and the smallest is equal to 2021. So this will be x squared minus 4 equals to 2021. X squared equals to 2021 plus 4, that is 2025, and it is equal to 45 squared. And since it is positive integer, x will be equal to 45. Since x is at the middle of the 5 consecutive integers, so the sum will be just equal to 5 times 45, that is 225. And therefore, 225 is the answer for question 9. So for question 10, we have a special number j. This number j is formed from the number 1 to 2021 form it together. So the question asks, what is the remainder when j is divided by 6? A number is divisible by 3 if and only if the sum of the digit is divisible by 3. So we can say that j is congruent to 1 plus 2 plus 3 all the way to 2021 mod 3. And this equals to 2021 over 2 times 2022 mod 3. And this is 2021 times 1011 mod 3. It is 2043231. If we take the sum of the digits, again it is divisible by 3. Each of these divisible by 3, 2 plus 1 divisible by 3, 2 plus 4 divisible by 3. So this is congruent to 0 mod 3. Now what does it mean here? It means that j is a multiple of 3. J is a multiple of 3, and j is an odd number, and therefore j will leave a remainder of 3 when it divided by 6. So 3 is the answer for question 10. For question 11, each of the letter represent a different digit, and is given s equals to 6 and e equals to 8. We are asked to find what is the value of XIX. Let us fill in the blank. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5, 6. We already know that s is equal to 6 and e equals to 8. 8, 8, 8, 8. Now obviously, t must be equal to 1. T equals to 1. And this is 16. Now become 8. So 1 must be carried in front. So this will be equal to 3. So W is equal to 3. And T equals to 1. We can fill it here as well. Now because this is 16 and this is 8, there must be 2 to be carried forward. So this V must be at least a 7. So we left with 7 and 9. Now, E cannot be equal to 9. Otherwise, this will be a 6. Because this is already 16, it will carry 2. And N will be equal to S. So v cannot be equal to 9, and therefore v has to be equal to 7. So v equals to 7, and from here we have this n will be equal to 2. And now we know that n equals to 2, so this will be 2 and 2. And now we still left with 1, 2, 3, we still left with 4, 5, 6, 7, 9, and 0. We still left with 4, 5, 9, and 0. Now we know that x cannot be equal to 4, otherwise this will be equal to 8. X cannot be equal to 4. If x equals to 5, then this will be equal to 9. There's no valid value for I. So x cannot be equal to 5 as well. X cannot be equal to 9, otherwise y will be equal to 3. And therefore x can be equal to 0. X is equal to 0. And therefore y has to be equal to 4. Now I has to be equal to 5. And this is a valid possible sum. So to answer this question, the 6 that we have is equal to 650. So 650 is the answer for question 11. For question 13, a to I are all numbers that satisfy all these 7 equations. Based on the condition, when we have the value of a, b, and c, then we can get the value for the rest. And from here, we want to find out what is the sum of a plus e plus I. If the value of a, b, c are known, then the rest of the value of d to I will be also known. Like a to be x and b to be y. So from here, c has to be equal to 1 minus x minus y. So b and c, in order to get a 2, it must be 1 plus x. Then we will continue. In order to get a e, this will be 1 plus y. And for the fourth equation, 1 plus x, 1 plus y. In order to get a 4, this is 2 minus x minus y. We will continue. 1 plus y, 2 minus x minus y. In order to get a 5, I need to have a 2 plus x. Then for the next one, 2 minus x minus y, 2 plus x, then it will be 2 plus y. Lastly, 2 plus x, 2 plus y, and it should be 3 minus x minus y. And therefore, the corresponding value of a, e, and I will be equal to x, 1 plus y, 3 minus x minus y. So this will equals to x, 1 plus y, 3 minus x minus y. And x and y will be cancelled off, and the value is equal to 4. So 4 is the answer for question 13. So now we come to the question 14. For any 3-digit number x, we define the big mx and the small mx as the largest permutation of the 3-digit x, and this is the smallest of the permutation of the 3-digit. For example, m of 1, 2, 3 will equals to 3, 2, 1, and small f 1, 2, 3 equals to 1, 2, 3. Okay, so let's say now z is a 3-digit number such that z equals to m of z minus small m of z. We are asked to find what is the value of z. So let's say z consists of the letter A, B, and C, where A is the largest and C is the smallest. Okay, so m of z will be equals to A, B, C, and small m of z will be equals to C, B, A. And the difference of this will be another 3-digit number, z. If so, then we'll look at each of the digit of z. So we know that C is smaller than A, then this will be 10 plus C minus A. This is B minus B, but 1 borrow to the next digit, so this must be equals to 9. For the first digit, it must be A minus C minus 1. And therefore, we know that out of 3 digits in the number Z, 9 must be one of them. And therefore, A has to be equals to 9. A has to be equals to 9. Then, from here, we know that A minus C minus 1 must be equals to 8 minus C. And 10 plus C minus A must be equals to 1 plus C. And therefore, 8 minus C, 1 plus C, it must be either equals to B and C or C and B. Obviously, this is not valid. We will obtain 1 equals to 0. So this is not possible. And therefore, we will have C equals to 4 and B equals to 5. 954 minus 459. And this will equals to 495. And 495 will be equals to this Z. And therefore, 495 is the answer for question 14. So this is the end of today's lesson. And for tomorrow, we'll discuss some geometry question from SMO2021 Junior section. I'll see you again. Bye-bye.